All right, question 19, we've got three different phases of sulfur trioxide, right? Solid, liquid, and gas. What are the absolute entropies of the solid, liquid, and gas phase of those three? Right? Well, in general, we know entropy increases as I go from a solid to a liquid to a gas, where solid should have the lowest entropy possible. Gas should have the highest entropy possible. So we're going to do the same thing here. So sulfur trioxide solid should have the lowest entropy. It should be associated with C. The liquid should be in the middle. So that's going to be choice A. And then the gas should have the highest entropy, right? So that should be choice B, because that has the highest entropy. Question 47 from the homework, where we needed to determine the amount of heat required through phase change. Did you end up having to use temperature equals delta H over entropy? Okay, I'll take a look after this. Question 20, right? Choose the process where our change in entropy increases. So we can increase entropy through phase change, through temperature, through increasing number of moles, concentration, increasing volume. So if we go and take a look at these, there's more than one correct answer for question 20. Right, if we take a look at choice A, I've got 4 moles going to 2 moles and gas going to gas. So no, entropy is decreasing here because I'm going from 4 moles of a gas to 2 moles of a gas. That's a decrease in moles, decrease in entropy. Here, however, this would have a positive change in entropy because I'm going from 2 moles of a liquid to 3 moles total, and they're all gas, and gas. So I've got two things going for me. I'm increasing number of moles, and I'm going from a liquid phase to the gas phase. Here, I'm going from gas to solid. Moles are the same, so phase change is the main thing going on. That's not favorable, right? Because the phase change. I'm going from something that has more entropy to something that has less entropy. We know choice D, I'm going from a solid to something in solution. So really I've got sodium ions in solution. I've got chloride ions in solution, right? And so that's also going to be favorable. So I'm increasing the number of moles. And then let's see, hydrogen reacting with chlorine to form HCl. That one's kind of a tie because we'd have to do the calculation for this one because I've got 1 mole and 1 mole. So, right, 2 total moles going to 2 total moles, gas, and gas. So this one, it's hard to say, right? If we're gonna have a positive change in entropy, we really would need to look at to see if this is spontaneous. We'd have to calculate our enthalpy for that reaction. But definitely with B, we've got an increase in entropy. D, we've got an increase in entropy as well for question 20. All right, question 21, surfactant. Oh, there were more to that. A, B, C, D, E, we've got F. I thought there were 3 correct answers. So F goes with question 20. And let's see, we've got gas going to gas, and now I've got 9 moles versus 10 moles. So yeah, question F, we'd expect to see a positive change in entropy, or premise in the in reaction F there. We'd expect to see a positive change in entropy because I'm going from 9 moles to 10 moles. Question 21, right, this surfactant, the hydrophobic Yeah, you only had to select one correct answer. There were multiple correct answers. Question 21, we're looking for the hydrophobic portion. The hydrophobic portion is afraid of water. It's non-polar, right? Because water is very polar. And our non-polar, right? Our classic example of non-polar region, carbon, hydrogen, right? That is non-polar. So anywhere in this region, right, is the non-polar part of this molecule. And yeah, Karine, on the real exam, there will only be one correct answer. All right, 22, 23. Entropy. So we want to find the entropy for this reaction. Oh, okay. Yeah, we can do 23 too. 23 is pretty easy. So for question 22, right, it's a summation calculation. So change in entropy equals the sum of, right, my moles and the entropy, my products, minus the sum of how many moles and the entropy of my reactants. So my entropy here, I've got 2 moles of carbon dioxide at 213.8 joules mole Kelvin, minus the sum of my reactants, 2 moles of carbon monoxide at 197.7 and 1 mole of oxygen at 205.2. And I dropped the units, but they should be joules mole Kelvin. Multiply by our molar coefficients, right? So we multiply by 2, moles cancel out, multiply by 2, moles cancel out, multiply that by 1. Add, we're going to add, multiply and add those two together, and then we're going to subtract that across. So 417, right, 0.6 joules per Kelvin minus 427.6 minus 197.7 plus 205.2, 606 joules per Kelvin. So decimal places, right? We're going to have to answer this to 4 significant figures, which is 1 decimal place. So 400. Right, we subtract across 600, and I'm going to get a change in entropy for this reaction of about 173.0. So negative 1.730 e to the 2 should be our answer to 4 significant figures. When you put the 2 together, like if you had to calculate delta G, after doing a summation calculation, yeah, you're going to have to do a conversion where you convert entropy from joules into kilojoules, for example, or you'd convert delta H enthalpy from kilojoules into joules, because entropy is always measured in joules because it's a smaller number. Enthalpy is typically measured in kilojoules because it's a much larger number. So yeah, usually there's going to be at least 1 unit conversion for energy there. And then for question 23 is just another way of saying the 3rd law of thermodynamics, right? For a pure crystalline solid at absolute 0, right? Minus 273.15 degrees Celsius. I guess the Celsius was dropped there for some reason. That probably made that a little bit harder. But at absolute 0 Kelvin, there is zero entropy, right? Because there's nothing moving, there's only one microstate. There's no other possible arrangements. So entropy is zero at absolute zero. All right, any other questions on the practice exam?